4.5 billion years ago, a massive, swirling cloud of gas and dust quietly collapsed in on itself. As the pressure built, it ignited, burning away the darkness to form our sun. That single fiery birth consumed 99% of all the matter in our solar neighborhood. Exactly 1% of that ancient nebula was left behind, spinning out into the cold. Every planet, moon, and asteroid you know, every mountain and ocean, was constructed entirely from that leftover cosmic scrap. The first thing formed from that debris is Mercury. It is tiny, only about 4,800 kilometers across, yet 70% of its interior is a massive, solid iron core. Sitting so close to the sun, surface temperatures here reach over 800 degrees Fahrenheit. But looking at the deep shadows in these impact craters, scientists have found ancient deposits of frozen ice that survive the blistering heat. Move out one orbit and you find Venus. It shares Earth's size and mass, but those thick, yellowish-white clouds you see here are made entirely of sulfuric acid, masking a surface littered with active volcanoes. The atmosphere is nearly pure carbon dioxide, trapping heat at 900 degrees. The air is incredibly dense. Standing on Venus subjects you to 1,500 pounds of pressure per square inch, delivering the exact same crushing force as standing deep at the bottom of Earth's ocean. To make matters stranger, Venus rotates backward compared to the rest of the solar system, and it turns so slowly that a single day there actually lasts longer than its entire year. Proximity to the sun dictates the rules here. The inner solar system is defined by blistering radiation, toxic atmospheres, and heavy compressed rock. Skipping past the blue sanctuary of Earth, we reach Mars. The sky here isn't blue. The thin carbon dioxide atmosphere filters the sunlight into dusty shades of pink and red. We think of earthly peaks like Mount Everest, shown here, as massive. But Mars hosts a volcano called Olympus Mons that stands nearly 3 times higher than Everest, towering 22 kilometers into the Martian sky. Past Mars lies the asteroid belt. Millions of jagged rocks form a physical boundary line, separating the dense terrestrial worlds from what lies beyond. Mars is the final outpost. It is the absolute limit of the rocky, solid ground in our solar system. Crossing that boundary brings us to Jupiter. As the largest planet, its immense gravity acts like a giant vacuum cleaner, actively sweeping up rogue asteroids and pulling them away from the inner planets. Looking right at the southern hemisphere in this image, you can see the Great Red Spot. That single storm is twice the size of our entire Earth, and it has been churning violently for over 400 years. Despite its massive volume, Jupiter spins incredibly fast, completing a full rotation in just 10 hours. It commands a system of 95 moons, including Europa, an ice-covered sphere hiding a vast liquid ocean beneath its surface. Then there is Saturn. It is the second largest planet we have, yet its internal structure is composed of such light gases that if you could find an ocean large enough, the entire planet would float. The defining feature, these wide rings, are not solid bands. They are made of countless billions of shattered asteroids, dust, and crushed ice, constantly orbiting the gas giant. Out here, solid ground disappears completely. The outer system is ruled by vast spheres of turbulent hydrogen, helium, and freezing storms. At nearly 2 billion miles from the sun, Uranus drifts in the dark. Unlike the vertical spin of every other planet, this ice giant orbits knocked completely onto its side, rotating at a 98-degree angle. Further out is Neptune. The isolation here is profound. Light leaving the sun takes over 4 hours, a full 250 minutes, just to reach the top of its atmosphere. To put that distance in perspective, the Voyager 2 spacecraft, pictured here, had to travel at roughly 35,000 miles per hour for 12 straight years to arrive. And when you arrive, you find this bright blue atmosphere torn apart by supersonic winds blowing over 1,200 miles per hour. Deep inside, the crushing pressure causes carbon to crystallize, forcing actual solid diamonds to rain down through the gas. Extreme distance from the sun doesn't result in a quiet, still environment. It yields violent, frozen chaos. Finally, we cross into the Kuiper Belt. Here we find Pluto, seen clearly with its distinct heart-shaped glacier. It is the most famous of the frozen dwarf planets, sitting right on the edge of interstellar space. This entire outer belt operates like a massive cosmic graveyard, filled with millions of jagged, icy remnants that never quite formed into worlds during the system's violent birth. From the acidic volcanoes of Venus to the diamond rains of Neptune and the frozen plains of Pluto, every single thing we have seen was built from that same 1% of leftover dust. If you want to explore more of our cosmic neighborhood, hit subscribe and join us on the next journey.